Hi, I'm Gary, and this is episode 156 of EV Musings, a podcast about renewables, electric vehicles, and things that are interesting to electric vehicle owners. On the show today, we'll be looking at converting your current car to electric. This season of the podcast is sponsored by ZapMap, the free-to-download app that helps EV drivers search, plan, and pay for their charging. Before we start, I wanted to say that I'm just a couple of weeks away from recording the roundtable episode for the end of the season. I've got the players identified, I've got the topics selected, I just need to get a time sorted for recording all this. Our main topic of discussion today is EV conversions. Typically, when I say EV conversions, the image that comes to mind, if any, is of someone taking a beloved old or classic petrol car, ripping out the engine and transmission, and replacing it with some usually Tesla running gear. And there are numerous examples of people doing that. The Ferrari 308, the Magnum PI car that was converted recently, went from being a standard prancing horse Ferrari to being something that beat the original spec in just about every metric: acceleration, torque, top speed, etc. So there is a case for conversions such as these. They keep cars that people might want to use for treasure purposes, but they also allow them to be run using renewable energy and, more importantly, keep them running after whatever date the government mandates for the removal of fossil fuel cars from the roads. But there is another side to this which people might not have realised. Converting pretty much any car to electric is entirely possible. The only thing really keeping you from doing this is usually cost. And one reason for this is that many EV conversions are done, as I stated earlier, using Tesla running gear. You buy a Tesla battery, a couple of motors, alongside all the electric gubbins needed to allow it to charge, etc., and off you go. But is this something that everyone can do? Today, I'm joined by Richard Morgan from Electric Classic Cars. Richard has classic car DNA flowing through him, having owned, restored and raced various classics since the age of about 17, I think. He also worked in the energy efficiency industry for the past 20 plus years, helping some of the world's largest organisations reduce their carbon emissions. Welcome, Richard. Thank you for joining us.
Good to see you, or not to see you, but to be with you, Gary.
I want to start off by asking the same question that I ask most of the guests that come on here. What was your path to EV ownership? What got you from where you started to where you are now, very briefly?
The energy efficiency industry that I was in previously, we had Toyota Priuses as company cars. And this is going back to, very early days of Toyota Priuses. So we adopted hybrid technology, probably 20 years ago now. And, my daily driver was a company car, Toyota Prius. My weekend warriors were VW Beetles. And I also used to race and rally Porsche 914. So when I finished that professional sort of like life, when we sold that business, my eyes sort of like turned to my classic cars in the workshop and thought, right, what can I do next? And we looked at a number of options for new electric cars. And having never really been a fan of new cars, full stop, I was under-impressed, let's say, with new car options like Nissan Leafs and BMW i3s. I just thought, well, how hard can it be to convert one of my own cars? So my first ever electric car was actually a car I converted to electric myself. So that's kind of how I got into it.
All right, well, let's talk a little bit about the company that you're with at the moment. How long has that company been in business?
So, must be about 7 years now, I reckon. It kind of spawned from that first car that I converted. So I converted a VW Beetle, and when I converted that Beetle, I kind of, got a lot of traction online, and people were interested as to what I, did and how I did it. So off the back of that first Beetle, which is my own, we got I got somebody contact me to say, hey, can you convert a Porsche 911 for me? Evenings and weekends are like hobby conversion on that. Halfway through that, I got somebody contact me regarding another vehicle to do. So I very rapidly, within about 6 months of converting my first car, started to get a waiting list, if you like. So I kind of took the decision to knock the day job on the head and turn my hobby into my business. And it's now 7 years later, and we've got a hobby that's got out of control, as my wife likes to call it, and about 68 cars in the order book, and probably the largest converter of classic cars in the world now.
And how many do you estimate that you've actually done in those years?
Oh, it's upwards to probably around 100 cars now. We've got 18 cars in the workshop right now getting converted. And as I say, I think something like 68 cars in the order book that we've got to get converted. And they range everything from small little cars up to, supercars. But they're all classic cars. They're all something from the 1950s through to maybe the early 80s. My interest in classic cars wanes as soon as plastic was invented for dashboards.
Talk to me a little bit about the process. I mean, you've talked there about the sort of cars that come in. Are there specific vehicles that are more suited for this, or is it possible to convert anyone, given the fact that you have a fairly malleable cut-off line about plastic or no plastic on the dashboards?
Basically, any car can be converted to electric, really, but it's just a scale of complexity. I mean, even modern cars can be converted to electric. You've got more, CAN communication going on. So that's a computer protocol, if you like, that's communicating to lots of things within the car. But, any car practically can be converted to electric. It's just an order of magnitude of complexity. And the thing that I like about classic cars, as far as conversions are concerned, is they're very simple mechanically and electrically. So when you are taking out an engine, there's no computer system on board that will, have a problem with that. So, I would say the simplest cars to convert are older cars that have less complexity in them. Apart from that, everything is just a scale of complexity up from there, but there's certainly no car that can't be converted to electric.
So with the conversions that you do, are they, I'm going to use the word retrogradable, and what I mean by that is I read somewhere that somebody did an Aston Martin conversion and they'd left everything as it was so that if a future owner came in and decided they didn't want the electric powertrain, they could take everything out and replace the engine, the transmission, the fuel tank and everything, and it would be exactly as it was before. Whereas I know a lot of conversions, you end up having to reroute things and maybe cut a new hole in somewhere to put a charge connector in or something like that. So where do you fall on that sort of spectrum?
So my feeling has always been that we are the custodians of these classic cars for the next generations. So you shouldn't be cutting and shutting and welding and doing modifications that can't be reversed on a classic car. So all our conversions are completely bolt-in and reversible. So if anybody wanted to in future, not that anybody has, but if anybody did want to, they can take that electric drivetrain out and simply bolt back in the petrol or diesel engine and the fuel tank and the exhaust system. All our systems are completely bolt-in and reversible. We reuse existing engine mounts and other infrastructure within the car, and that's, as I say, done primarily because you have to respect the fact that this is a piece of motoring heritage, if you like. You shouldn't be messing around and modifying it. But also from a regulation point of view in the UK, you shouldn't be modifying a monocoque body or the chassis when you're doing a conversion, because then you will invoke the wrath of the DVLA and the IVA point system in relation to radically altered vehicles. So, it's a good idea to avoid doing any modifications in that respect. But from a moral and ethical point of view, you shouldn't really be, certainly for classic cars, be, cutting big holes in and, welding new stuff into a vehicle when you're doing a conversion.
And are all the conversions bespoke? By that, I mean, is there a basic kit that you put in, or do you have to look at each particular vehicle that comes in and says, right, we'll need to do this kind of battery to fit into this chassis, this sort of motor to replicate sort of what was there before? How does that work?
It's probably somewhere in between is the reality. So you've got to bear in mind that because we've been going the longest converting classic cars, and have got quite a catalogue of cars that we've converted in the past. Over the past 7 years, we've evolved bolting kits for various repeat type cars. So, Fiat 500s, Porsche 911s, Land Rovers, etc., Minis. We've got a very evolved and tried and tested solution for a bolting kit to, allow us and our partners to convert classic cars with those bolting kits. And those bolting kits are not like some kits out there that I've seen where it's just essentially a list of parts and, including a reel of cable, and you've got to wire it all up. And, these kits that we're talking about here are completely tried, tested, bench tested. We spun the motor up. It comes with a high voltage loom with all the connectors on, the low voltage loom. So all cut to length. So this is just simply something that you bolt in place, mount the cables and plug the ends of those cables in. So it's a very simple kit. So we've developed bolting kits. I think we've got something like 7 make and models of vehicles covered now, and that increases as time goes on. But equally, there's lots of cars that come into the workshop that we've never seen before, and I'd probably say 2/3 of the car that comes through the workshop we've never seen before. I mean, we've got an Aston Martin, as you mentioned before, in the workshop now. We've never done an Aston Martin V8 before. We've not done a Maserati Ghibli 1967 before. We've, certainly not done Ferrari Testarossas before. So, a lot of these cars come into the workshop. It's the first time we've, seen them. So then you have to go through that, engineering and analysis and assessment phase where you're trying to figure out what motor can fit where, what battery pack can fit where, space-wise, but also weight-wise, and whether or not it's going to meet customers' expectations as far as the car is concerned, depending upon power and range. So it's kind of an iterative process when you're converting a car you've never converted before, but there's a lot of things to take into account when you're doing that.
Are there any cars that come in and you look at them and you think, I really don't know how we're actually going to do this one? Or are they all pretty much, we might have to finagle this or that, but we can do it?
Look, as far as challenges are concerned, engineers love challenges. As far as, moaning about, this is going to be difficult, this is going to be a nightmare, inside, any engineer really is going, they're rubbing their hands together thinking, this is going to be great. How on earth are we going to do this? And there's certainly cars coming into the workshop like that. I mean, one that comes to mind is a BMW Isetta came in a few years back. That was obviously a very small 1950s bubble car, tiny little thing, 3 wheels, powered by a glorified motorcycle engine. And you just look at that thinking, where on earth are you going to fit the batteries? There's just no space whatsoever. So we do have a number of cars that come in where you just scratch your head for a bit and go, this is going to be a nightmare. But you overcome that, you figure it out, you work the problem through. And, in that BMW Isetta, for instance, we discovered that underneath the front seat, but there's no back seats, there's only one seat. Underneath that front bench seat, there's quite a bit of space. So we ended up putting a decent sized battery underneath there. And again, that battery being nice and low, good for handling, but also, give it a decent amount of range. But you also have to bear in mind, you can't put too big a battery pack in because, that car can't carry the weight. So you always have to be mindful of weight constraints of a vehicle, as well as space and form factor of available, space where you can fit these things.
Now that brings up an interesting question. If we go back to the Isetta for a second, when the owner came in and said, I want this converting, at some point you will have gone back and said, right, we've had a look, we can put a battery in here, here and here. This is what the final range is probably going to be. And that's limited by the fact that we can't put this size of battery in, we've had to put that side of battery in. Is there a point there at which the customer might come back and go, actually, no, I don't think that's worth it. I was expecting more. Or do they all pretty much go, yeah, okay, that's fine. If that's what you can do, that's what you can do?
It's pretty much the latter, to be fair. I mean, if a customer comes in expecting a 500-mile range out of a Mini, then their expectations are so far off that probably, electric isn't for them yet. If they've really done their homework, they should know what kind of range is, going to be not just practical for them, but also in line with other vehicles. You can't put a full Tesla Model S battery pack into a BMW Isetta, for instance. But on the flip side, it's a very small car. It only has 3 wheels for rolling resistance. So by the time we'd finished that car, bear in mind a BMW Isetta is only really designed for urban use. You wouldn't see any on the motorways, so range is less of an issue. But for small cars like that, you're not going to be able to fit in a massive battery pack. So from memory, I think the BMW Isetta was around about 100-mile range. Was it, John?
Yeah.
Yeah, about 100-mile range was the BMW Isetta, which, in the city of London, you'll struggle to do 100 miles in a week, maybe even 2. So for the use case of that car, it was pretty spot on.
Talk to me about the timeline. Is this something that can be done in a weekend for a car, or is this something that is going to take considerably longer than that?
Well, again, I mentioned the kits before, the bolt-in kits. We have converted a car in a day before. On our YouTube channel, for instance, there's a video of us converting a VW Beetle in a day. So it's just starting in the morning, finishing by early evening. And, that is definitely possible. But it all depends upon, A, getting a very good bolt-in kit, and B, having more than just one person working on that car. We had, during the day, probably, a maximum 4 or 5 people working on it, and, that helps. But in reality, if you're converting a car, like, as a business like we do, I'd say the average conversion time is a few months. But again, there are certain instances where we can do it shorter than that, and certainly lots of instances where it's a lot longer than that, because, we're converting 18 cars at the same time. So everybody's not just working on one car all the time. It's a little bit like spinning plates. You work a little bit on one car, get that to a certain point, then work on another car, then back to another car, et cetera, et cetera. So, worst case scenario, you can have a conversion take, a year, for instance, depending upon the complexities of the conversion, whether or not we converted it before, et cetera, and all the other options that customer might want on that vehicle. And certainly if there's something new that we're trying, like vehicle to home or whatever technology, then, we got to thoroughly test that at the end as well. So there's, not just the build time and process, but also the testing phase as well, which can be quite long.
Do the conversions that you do you tend to fit CCS charging into all of them, or do you limit it to AC, or what? How does that work?
Yeah, with CCS is something we fit to a lot of our conversions, but a number of people don't need it and don't want it, or actually can't have it because of the voltage. So yeah, CCS is definitely something that's revolutionised the conversion market, if you like. It's brought everything in line with a production car, and in some instances better, because the CCS is actually faster than some production cars that have CCS. But some customers, like that BMW Isetta, for instance, that will never go near a CCS charge station in its life. It's basically just going to be charged up at home, maybe now and again at Tesco's when they go shopping, but it's never going to do long journeys and require CCS. So, some cars don't have CCS because, the customers are just never going to need that. But equally, CCS only supports pack voltages of 200 volts or higher. So, if you've got, a pack voltage that is lower than that, you're not going to be able to use CCS. So from a technology or technical point of view, some vehicles can't use CCS either.
Well, let's dig into that a little bit in terms of, you've mentioned the kits that you've sort of put together because you get certain cars that come in that are, sort of repeat cars, the Beetles and that sort of thing. What do you tend to stick to a specific type of running gear? So, for example, do you always use sort of a Tesla kit, or would you pick and choose from different parts suppliers?
I'd say 40% of our builds use Tesla. A lot of people, think we only use Tesla, but that's usually because the higher end builds, high performance, etc., that look good on TV or YouTube, and get that wow factor, normally have a Tesla motor in because they're the powerful motors. But in reality, I'd say 40% of the cars, maybe less, have Tesla motors in, and the others we have a range of different motor manufacturers that can supply us motors, and within those manufacturers they have different motor ranges, if you like. So I'd say we've got 3 main manufacturers we use for motors, and as I say, within those manufacturers they've got a catalogue of different motors that we can use.
I mean, this is anecdotal, but I've got no reason to disbelieve it. Was it a Testarossa or maybe one of the Magnum Ferraris? Was it the 308s that got converted? And after the conversion had happened, the performance on the vehicle was very much better than the original spec of the Ferrari as it left the factory. Is that something that you would expect on conversions that you do, or does that very much depend?
Yeah, so we've done 2 Ferrari 308s now, and you're right, we've also got the Ferrari Testarossa. In fact, we've got 4, if not 5 Ferrari Testarossas that are getting converted at the moment. But yeah, the original Ferrari 308, everything was better, quite frankly, after we converted it. I mean, not just the reliability or the running costs were less, but it weighed the same, if not slightly lighter. Weight distribution was better. Handling was therefore better. Performance was insanely better. The Ferrari 308 was never really a powerful Ferrari performance-wise. And when you stick a Tesla motor in and get 0 to 60 in whatever it was, 4 seconds, I mean, that's, a lot quicker than the original Ferrari was. For instance, you mentioned Magnum PI there. Whenever you saw the Ferrari doing a wheel spin, like at the opening sequence on Magnum PI, it was always on either gravel or grass because they could never get it to wheel spin on tarmac. But with a Tesla motor in, you can get it to spin the wheels on sellotape if you wanted to. It's that much torque.
That's fantastic. I like that. So, of course, the big question that a lot of listeners are going to want to know is what sort of cost are we talking here? And I realise it may be, how long is a piece of string? But do you want to give some ballpark figures, please?
Yeah. So getting a car converted by a professional company is, not going to be cheap. I mean, we've got to build to certain safety standards, like R100, for instance. We've got to use, certain components come with warranties, etc., etc. So, conversion cost for us would start at something like £20,000 for a small, a car that you'd use around the city, right the way up to, I think customers have probably spent, maximum £120,000 with us to convert a car. So it's not a cheap process to convert a classic car by any means, but there are huge benefits once you've done that. But if anybody is looking to convert a classic car from a financial, economic point of view to say, well, if I do this, what's the payback period going to be? That's never going to happen. I mean, it's a bit like saying, if I'm going to build a patio, a new patio on my house, what's the payback period going to be? You do it because it's, A, the right thing to do, and B, it's going to make your life more enjoyable and you'll get more enjoyment out of that asset. It's primarily not an economic decision that clients choose to convert the cars. It's all the other benefits.
What are the insurance implications for a classic car that has been converted to electric?
So it's pretty similar to modifying any car. So I mean, you can't go to your average insurance company that you insure your Ford Focus with. You'd go to a specialist like Adrian Flux or Footman James or whatever that already insure classic cars, but also they insure modified classic cars. So, for instance, if you put a Honda Vita engine into a Mini, they insure cars like that. So you just have to go to insurance companies that are used to dealing with modified vehicles. And it's as simple as that.
From a business point of view, you've obviously talked about the orders that are on the books there. So I would imagine you've got enough work for the foreseeable future. But can you take on more work with the current staff, or do you need more engineers / mechanics, etc.?
Yeah, we're always expanding. I mean, our order book is always growing, and the staff here is always growing in line with that. We're just about to extend and expand the workshop here by another 50% as well. So, the potential, future potential for this market is absolutely huge. And for us to maintain our market position as the leaders in this marketplace, we need to, grow at some pace. So, yeah, we're always growing the business with staff and, expanding and also expanding our partnerships with other companies around the world that we supply kits to. We supply, Land Rover kits to the US. There's a company out there called ECD that we ship lots of Land Rover kits to. There's Gildred Racing in California that's a mini specialist. We ship mini kits out to them. So we're always growing our partnership program as well, which is another way we expand the business.
So as a business owner, what keeps you awake at night when thinking about the business that you're running and electric car conversions in general?
Keeps me awake at night, I would say, just the excitement, I suppose, of the potential growth of this market. I mean, the classic car market that I've been in for 30 odd years, it's kind of slowly been shrinking as there's less classic cars out there, and the people that are into classic cars get older, etc. I mean, there's precious few younger people getting into classic cars like there was when I was younger. So, with that classic car kind of slowly shrinking, this electrification industry that's sprung up has kind of injected a new lease of life into it. And, it's sort of things that keep me up at night are less, worries and concerned. It's more the adrenaline of excitement that keeps me up at night. The fact that I just, have so much, enthusiasm for the future of the classic car market, because having owned and driven, electric converted cars now for 7 years, I know that they're so much better than when they were petrol. And, if I can be converted, being a petrol head for the previous 23 years, a huge petrol head, if I can be converted to electric conversions in classic cars, then I know everybody else can. So that's probably what keeps me up at night. The excitement that knowing the potential for this market is just insanely huge.
So that's the point of view from someone who's done literally hundreds of these. They're professionally done, different size batteries, vehicles that can be taken out on the road and run in a day-to-day setting. But as you can hear from Moggy's discussion, these are not cheap. The man hours alone mean that this can be an expensive proposition, and Tesla running gear doesn't come cheap either. So, is there an alternative? A cheaper, less complicated DIY option? Well, yes, there is. I'm joined by Tom Cheesewright. Tom's Twitter bio says he's, quote, an applied futurist, sharing a clearer vision of tomorrow on stage, on air, in words, and in boardrooms, close quotes. Well, that's as may be, but we're here today to talk to him because he's one of those crazy people who decided to convert a car to electric by himself. Welcome, Tom. Happy to have you here today. Let's start with the big question. What car did you convert?
So we looked around at who was doing kit cars, or rather body conversions, first of all. I wanted something relatively modern so that it had some safety features. If you're going to be moving your kids around in it, and by and large, my car only gets used for taking one kid or another to a club or some variation on that theme. I wanted some safety features, but I wanted these classic looks. So it was really a question of who does body conversions for modern cars that might work. So initially we looked at MX-5s, sort of first or second generation MX-5s, but they have a horrible feature whereby the mechanicals are very robust, but the bodies rot. And so that was no good at all. I didn't want a working engine and a rotten body. I wanted a working body and a rotten engine. So instead, we went down the German route and looked at BMW Z3s, and there's a great series of conversion kits for those to allow you to make them very pretty and retro. And so I bought an MOT failure BMW Z3. In the end, it turned out to be very rotten in the body as well. But we got past all that with sufficient application of welder and steel.
Well, now, obviously, as this is an episode about electric vehicle conversions, there are two paths to do this. And one is you could have taken the vehicle to somebody who does this professionally and has got all the equipment and all that sort of stuff. Or as you did, you decided to do it yourself. Now, I understand you're talking about the challenge on that, but was there ever a point where you thought, actually, I'm going to give this to the pros and let them do it?
No. And for the simple reason that I wasn't in a financial position to do so. It's not a cheap process to have somebody else do it, because even if you are using, as I did, sort of recycled parts, the number of hours involved at any sort of sensible hourly rate mean that the costs are going to add up. And having done it, I'm very conscious of why it costs a lot of money to have a professional do this, because even if you ignore the cost of the hardware, it is incredibly time consuming.
All right, well, let's dig into the details a little bit on that. Talk me through the process of taking this BMW, bringing it in. And so you started with the MOT failure and you ended up with an electric vehicle at the end of it. What was the process?
So the first thing you do is take the motor out. You take the motor out, you take the fuel tank out, you take all of the ancillaries associated with that out, which does cause some problems down the line because you're taking out things like vacuum. So you've got no vacuum to drive a brake booster. You're taking out things like the power steering pumps. You've got no power steering. But you take all of that stuff that's connected to the old combustion engine out, fuel lines, all of that. So you've got an empty shell. And then the question is, what do you replace it with? And, actually we started with what do you replace it with before we emptied the shell. And you can go down a number of routes here. You can buy a kit off the shelf, and this is probably going to cost you, upwards of £10,000. Or you can use OEM parts. So you can use parts from wrecked or end-of-life cars. And that's what we did. So we bought a motor that used to live in a Mitsubishi Outlander PHEV. They have 3 electric motors in them. We bought one of the smaller front motors. You buy an inverter, which is the bit that takes the DC current from the batteries and turns it into AC and controls the motor. And you buy some batteries. And we bought an inverter that used to live in a Prius. They're very plentiful, they're very cheap, and they're massively over-engineered. And we bought some batteries from a BMW hybrid. Initially, we bought about 8 kilowatt hours of batteries for a BMW hybrid. And then to control all that, you need some sort of circuitry and software. And we used a thing called Open Inverter, which is this open source project. And you can buy boards that run this software that effectively lobotomize the existing brain from whatever OEM hardware you buy and take control of it externally to allow you to reuse stuff from whether it's a Toyota, Lexus, a Tesla, whatever brand of EV, Nissan Leaf. You can effectively reuse those parts now, but without reusing the whole car. And we put all that together on the bench. I say we because my eldest daughter was heavily involved in this project from day one. She was off school and during lockdown, she did a lot of the welding, helped me dismantle the battery pack, which, some people might say is not the best health and safety approach with a then 10-year-old. But, I taught her some things about high voltages. And we got it running on the bench. First of all, we got the motor spinning. And then we decided to bolt up the motor to the existing gearbox. We've got a very unusual thing, which is an EV with a manual gearbox. Which works absolutely fine. There's no clutch in there. The two are just connected together with a coupler we made in the backyard. I did have to buy a lathe to then remake the coupler because it wasn't straight. Yeah, we knocked it all up with a welder we found in a skip, mostly architectural steel actually. And it took us 15 months all in to the point where we had a running car with relatively limited range, about 25-mile range. That had got through its MOT. It only took us about a year to get it up to a point of a running car, but it took us about 15 months to get it to the point of actually going through its MOT.
So if I sort of rehash what you've said there, you've got BMW hybrid batteries, you've got motors from an Outlander PHEV, you've got an inverter from a Prius, and you've got open source software controlling it all. Was there ever a point at which you thought, are we sure all these are going to work together?
Oh, I mean, daily. Yeah, absolutely. But the nice thing about this is there is a community there. You're never alone as a nerd in any domain these days, thanks to the internet. And that's particularly true of the DIY EV car sort of community. It's very active. It's very rich. It's full of a lot of people who are much smarter than me. And through a combination of, forum posts and jumping on Skype calls with some of the members of the community that I got closer to, we got there. And most people have trodden something of this path before. So no one had used the motor and inverter combination that we ended up using. That was novel. So we were a little bit sort of breaking new ground there. But I found other people who'd spotted these two things looked like good value and were doing the same thing at the same time. So other people were sort of ploughing the same path at the same time. And through that community, through that support, we got there. I mean, I haven't even covered half the range. There's a power steering pump out of a Vauxhall Zafira. There's a brake booster pump out of an Audi. Chargers also out of a Mitsubishi Outlander. I mean, it really is a Frankenstein's monster of a vehicle. But it works, and it's safe. It's MOT'd, and although I deliberately present myself as a little bit of an idiot on when I'm doing sort of YouTube videos and stuff, I do have a degree in mechatronic engineering. I'm not a total novice, and I'm very confident that what I've built is safe. As I say, otherwise I wouldn't let my kids ride in it.
Good points, well made. I appreciate that. Now, I saw an Aston Martin conversion recently where the people who'd done it had left everything as it was, so that a future owner, if they decided, could take the batteries and the motor out and replace it with the original engine. So it was exactly as it was before. So they'd taken the choice not to make any physical structural changes. Now, when you were looking at the changes that you had to do for yours, are you in that similar situation? If needed, could you get the old stuff or a similar version of the old stuff, the transmission, the fuel tank, the engine? Could you put that back in, or have you modified the structure of the vehicle in such a way that can no longer happen?
No, and I haven't modified the structure for a couple of reasons, or at least I didn't at first. I mean, firstly is the DVLA really frowns on that. And right now the DVLA is not very popular in the DIY EV community because it is it's basically pushing inspections on everybody looking to re-register their car as electric. And even the most minor modifications to the structure of the car are leading the DVLA to force people through an IVA, an individual vehicle approval. And there was a story the other day of someone who drilled a hole in their boot floor, I think to pass a cable or a bolt through. And even if they offered to weld it up, they were still forcing them through to have an IVA to allow their car back on the road. So most people who are doing this now, certainly in the UK, are trying to keep any structural changes to a minimum or actually doing none at all. And so in my case, I have made some changes since. I actually wanted to locate my battery pack more securely than I initially had it when it was first looked at. And so I've added a couple of tabs to give more mechanical location to my front battery pack to make sure it's sort of more, it can't possibly move around. But other than that, it's completely standard. And those could be very easily removed and the car returned to it if you really wanted to. Not that it's worth it for a £600 rotten Z3, but if you really wanted to return it to its previous status, you absolutely could. And I think with my next project, I'm working on my second swap already, and I'm doing another Z3. The plan is to have a summer car with a soft top and then do a winter car with a body swap to a hard top, sort of classic GT. I'm not going to make any modifications at all to the body. I'm going to find other ways to mount things without making these chassis modifications because, if the DVLA, when I come to re-register that one as electric, the DVLA may choose to inspect it and force me down through an individual vehicle approval if I've made any changes.
So where is the charger on the Z3? Is it where the old fuel tank nozzle used to be?
No, so at the moment, because there's so much space under the bonnet for Z3, and that was one of the things that really appealed. They usually have a dirty grey iron block straight six in there, plus all the ancillaries. So there's an enormous amount of space under the bonnet. So actually what I've got in the current car is my battery pack, my motor, inverter and charger and all my ancillaries under the bonnet. And there's still a load of space in there. Now, I don't want to put another battery pack in there because of weight distribution concerns. The second battery pack is going to go in the back. But yeah, all the important stuff is under the bonnet. And because of that great big space, it makes it very easy to work on as well.
So what exactly have you done in terms of the charger? Is it CCS? Is it just AC? What charge speed can you get from the charger that's in there in the inverter?
So right now, I'm just doing AC. I've actually only got a Type 1 socket on there and a Type 1 charger at home. Again, within the full DIY spirit. I picked up an old pod point for £30 on Facebook Marketplace and had my local Sparky fit it. So that was a very cheap home charging option. I am fitting CHAdeMO to it when it's gone through its body. It's actually back in the garage at the moment. I've rented some workspace because I got into this so much. And I did the first project completely on the drive. I've now got it undercover and I'm doing the body transformation and I will be fitting CHAdeMO. CCS is now a possibility. The BMW i3 charge controller has been reverse engineered. CCS is an awkward standard to do for a DIYer, but the community has managed it successfully. So I could add CCS if I wanted to, and I probably will add CCS on my new project. The aim of that one is to have a much larger battery pack. I'm probably going to go to somewhere between sort of 28 and 36 kilowatt hours, aiming to have 100 mile plus range and fast charging, so that will be able to get down to my folks in the Midlands from here in Manchester.
So from the 8 kilowatt hours that you've got there at the moment, what sort of range are you getting on the Z3 at the moment?
So I'm getting about 20 to 25. That's with no regen turned on at the moment. The open inverter firmware that runs my car is iterating constantly. There are new upgrades running all the time. People are extracting more power from the motor. People are making regen work better. And so, I didn't really need regen. The places I go in the car are to take my eldest daughter to ballet, my youngest daughter to gymnastics, or to take myself up to my garage to go and work on cars. So I don't really need more than about 10 miles range at any point, and I certainly don't need fast charging. So yeah, 25 miles is fine for now. If I added regen and some of the recent tuning, I could probably squeeze a bit more out of that. But actually, I've got a second pack ready to go in. The price of batteries, I know the price of new EVs is climbing, but the price of secondhand batteries is falling constantly. And so I've got a second pack ready to go in, which will double that up to about 50 miles range.
Oh, fantastic. Excuse me, what was the trickiest part of the project?
The trickiest part of the project for me was that ground between electronics and computing. I'm a sort of semi-competent amateur at both. And so I was never quite sure which one I'd got wrong. And so when I was troubleshooting, it was really challenging, and it still is to this day, to work out where the fault lies, whether I've got a connection wrong, whether I've got something like the resolver, which the resolver monitors the position of the motor and returns very precise information about where the motor is back to the motor controller. If you get the phases of the motor wrong or the resolver wired up wrong, you're never quite sure exactly what's not playing ball, or whether it's something in software or one of the many parameters you've got wrong. It's that uncertainty really that really caused me the most trouble. I wouldn't say I'm a good welder by any stretch of the imagination, but I got reasonably confident with a welding torch, and I have a good sense for the mechanical structure and what was required there. But yeah, that sort of hinterland between software and electronics was where I struggled the most.
How long did the whole thing take, start to finish, and how much did it cost?
So the whole project when we bought the first component, we decided to do it, and we bought the motor first of all. I remember I was in the back garden with my daughter and I saw a motor pop up on eBay at what the time I thought was a good price, which I think we paid £400 for it. I'd now be paying less than half that for the sorts of motor I'm using. But at the time, it seemed like a good price. I bought a motor for £400. And from that point to having a successful MOT, it took me, I think, 4 attempts to get through the MOT. But for a successful MOT, it was 15 months. And price, cost an interesting one. I could have been more frugal. I've got a friend who got on the road, including the car, for about £2,000, which is an incredible feat. That was my friend Jamie with his bug plug, which is an EV swapped Volkswagen Beetle, a modern Beetle. He bought the car and everything and did it all for about £2,000. For us, I think it was probably more like £3,500 to get on the road. But we're going to spend a lot more than that making it really nice. And that's the difference, I think, is, I'm building two cars that are going to be my cars for life. I'm just going to basically have one on the road and one off the road, upgrading constantly now for probably the next, fingers crossed, the next 30 years, or as long as I can get on my back underneath the car. So I'm not too worried about the cost, but you can absolutely, I think, even if you're not quite as frugal as a Yorkshireman like Jamie, I think you can buy a car and convert it for about £2,500 these days.
Now, given that you've done one already, you've got another one that you're looking at. What are you going to do differently on the next one from what you did on the current one?
So one of the things that has slowly reawakened during this project is my abilities with computer-aided design. And so the first car was built very much on the other sort of CAD. It was cardboard-aided design. It was, sketching things out, making cardboard templates, and then copying them in steel. And in steel that was, I could only find one steel stockholder at the time. I actually found another. I've found another one since, but the only steel stockholder I could find was selling mostly architectural steel. So we were sketching things out and making them on an old, very, very tired Black & Decker workmate. In the back garden with a welder, as I say, that we pulled out of a skip and restored. I'm slightly more sophisticated these days. I've now got a 3D scanner. My CAD skills have improved dramatically. And so the plan with the new project is to 3D scan the engine bay and all the components, design stuff on the computer, have parts fabricated off-site, so have things sort of CNC milled and machined, and then have a much sort of cleaner, tidier assembly that bolts into all the existing mount points, which the existing car largely does, but without me sort of putting things in the car and sort of welding them in situ to make them fit. I'm actually designing them properly and having them milled off-site. So in theory, when it comes to assembly, they all just fit. And in some ways, I'll miss the rather DIY fabrication. But I think it's time to take the car to the next level and make it look rather posher.
Now, given that the next car is going to have a bigger battery, obviously that's going to cost more. But will the process that you just outlined there with the 3D scanning, etc., will that decrease the perceived cost of doing that, or is that going to be a more expensive proposition?
I suspect it will be more expensive, although actually the batteries will be cheaper. So when we bought our first battery pack, we paid £800, and it's actually 7.6 kilowatt hours. We paid about £100 per kilowatt hour. I've already bought one of the packs for the new project, which is a later BMW hybrid pack. And the reason I like those is because of the way the connectors work. It's just really hard to electrocute yourself with them. I'm not saying it's impossible, but it's much harder than with some of the other packs that have got open bus bars. They're all covered on the BMW hybrid packs. But anyway, the later pack we bought is 12 kilowatt hours, and we only paid £800 for that. So you're looking at sort of an extra 5 kilowatt hours for the same price. And actually, I've got friends who've paid even less than that. They're getting down to about £50 per kilowatt hour. And if you're buying larger packs, you may be even going less than that now, down to about sort of £35, £40 per kilowatt hour. So in many ways, the second project, even with the cost of getting some parts professionally CNC machined, the second project may actually be cheaper, even though it's probably going to be more powerful and have a longer range.
That's very interesting, because obviously battery prices are dropping down, but to get to the kind of levels that you're talking about there, that's quite impressive. Now, obviously, we're going to have a lot of people listening to this who are thinking, oh, yes, I quite fancy doing that myself. So given what you've talked about today, given the kind of pitfalls that you've experienced, the issues that you've come across, what advice would you give for anyone listening to this who wants to convert their own car or a car that they're going to buy to electric?
So part of me wants to say, look, anybody can do this. But I've interviewed lots of people for my podcast now called DIY EV Chat, interviewing other people who've built their own electric cars. And I've not met one yet who's done it successfully that doesn't have some sort of engineering background, whether that is they've got experience working on cars, so they understand the mechanical side and they feel confident to go and learn the electricals and the little bit of code, or whether they've got the electrical or computing side and they feel confident going to learn some of the more mechanical stuff. You can bypass the gaps in your skills by getting external support and help, and lots of people have. They've paid fabricators to do some of the welding, or they've bought in sort of more complete kits to take some of the electronics challenge out of it. But I think if you're going to do this successfully, both for your chances of success and for your own safety, I think having a good, a reasonable background in some sort of engineering skill or practice is probably worthwhile. If you've got that though, and particularly if you're someone who's historically tinkered with petrol engines, I'd really urge you to go and do this because it's got that spirit of the old hot rod era. It feels like what I imagine it felt like in sort of those garages in California in the sort of 40s and 50s, with people, pulling cars apart and making things that are, sort of new and exciting and different and faster. And really sort of it's very innovative. There's a lot of change happening. The idea of controlling the OEM parts without having to pull them to pieces and lobotomize them just wasn't there 2 years ago when I started my project. Whereas now you can literally just plug in, you can buy a Nissan Leaf stack, which are very, again, plentiful, incredibly powerful. If you buy the whole stack, you don't have to do any soldering. You can just plug a control board into it and take control of that stack in your machine. So the electrical and coding requirements to do one of these projects is declining all the time.
So there you have it. Take the expensive option, hand your car over to a professional converter who'll get new batteries, inverters, motors, all the technical expertise needed to convert your current vehicle, provided it's reasonably old, to run on batteries. Or take the much cheaper route, source components from various places, leverage the expertise of a growing community of people doing this themselves and sharing their learning online. It might take you longer, it'll certainly be more of a learning experience, but it will be cheaper. Which one would you go for? Many thanks to Richard and Tom for coming on to the show and discussing their passions with me. It's time for a cool EV or renewable thing to share with you listeners. Housing is expensive everywhere, nowhere more so than in places like the United States. Plastic waste is a big problem. Lots of plastic is thrown away every day. Coca-Cola makes roughly 200,000 plastic bottles a minute worldwide. Well, what if we could link these two problems together and solve both of them? Well, a company called Azure is doing just that. Using massive 3D printing machines, they're creating prefabricated houses from recycled plastic and shipping them on site where they can be put together and connected to the foundations and utilities. There are a range of models on offer, from the 120 square foot studio that costs about $27,000 up to the 900 square foot 2-bedroom house that goes for nearly $205,000. All models come with solar panels and heat pumps. Each building is made of 60% recycled plastics combined with other materials to add strength and durability. The houses look stylish and smart, and I'd love to have one of the smaller ones in my back garden as an office. That'd be pretty cool. The EV Musings podcast is sponsored by ZapMap. ZapMap is the go-to app for EV drivers in the UK. Use it to search for available chargers, plan electric journeys, pay for charging on participating networks, and share updates with other EV drivers. ZapMap is free to download and use, with subscription plans for enhanced features such as using ZapMap in-car on CarPlay or Android Auto. And that's the show for today. Hope you enjoyed listening to it. If you want to contact me, I can be emailed at evmusings@gmail.com. I'm also on Twitter at MusingTV. If you want to support the podcast and newsletter, please consider contributing to becoming an EV Musings patron. The link's in the show notes. Don't want to sign up for something on a monthly basis? If you enjoyed this episode, why not buy me a coffee? Go to coffee.com/EVmusings. That's ko-fi.com/EVmusings. And you can do just that. Takes Apple Pay too. I have a couple of ebooks out there if you want to read something on your Kindle. So, You've Gone Electric is available on Amazon worldwide for the measly sum of 99p or equivalent, and it's a great little introduction to living with an electric car. So, You've Gone Renewable is also available on Amazon for the same 99 pence, and it covers installing solar panels, a storage battery, and a heat pump. Why not check them both out? Links for everything we've talked about in the podcast today are in the description. If you enjoyed this podcast, please subscribe. It's available on iTunes or wherever you get your podcasts. Please leave a review, preferably 5 stars, as it helps raise visibility and extend our reach in search engines. If you've reached this part of the podcast and are still listening, thank you. Why not let me know you've got to this point by tweeting me at MusingsEV with the words fuel tank out, batteries in, hashtag if you know, nothing else. Thanks as always to my co-founder Simon. We were talking recently about how he was never actually that interested in school. He said, I know I look like the school swap, but that's just not me. So I was interested to know how he managed to get the sort of high-paying technical job he has without that in-depth formal education. He told me,
You can bypass the gaps in your skills by getting external support and help, and lots of people have.
Thanks for listening. Bye.